All right, so we're going to talk to finish today. We're going to talk about pHs, and then we're going to have a tricky pH problem to work out first, and then we're going to talk about the salts. Okay, we're talking about pH of salts and what a salt is. So this pH problem is we're going to work it the same way for the most part, but there's a little bit of difficulty to it. Okay, so let me find my mouse. Okay, so I want you to calculate the pH of this. I want you to do this yourself right now. Work on your icebox. I'll come around and check it when you get done. Okay, so I want you to work this out. This is an icebox. Actually, fine. This is not an icebox problem, is it? Why is it not an icebox problem?
Because not a strong acid.
Okay, it's not a weak acid, so it's a strong acid. So work this out, and then I'll give you a second. So when you did this, you did negative log of 1.4 times 10 to the negative 8th because it's a 1-to-1 mole ratio, and you get solve it like that, and you get 7.85. But you know that hydrochloric acid is a what? Is an acid, regardless, and you know acid should have a pH of less than 7, correct? Okay, so that's why this answer is wrong. Okay. You have to use a little bit of common sense when you do this. You can't just blindly work the problem out and say, boom, that's the answer. You had to think about it. So what you had to go back and do is you had to go back and realize that, hey, wait a minute. I know that the Kw of water is 1.0 times 10 to the negative 14th. I know the Kw is 1.0 times 10 to the negative 14th. And I know that Kw is H plus times OH minus. So solving that equation out for Kw out, so I had Kw equal to x squared. So I know that X has a concentration, or hydrogen has a concentration of 1.0 times 10 to the negative 7. So to find the real pH, what you would have to do is you have to add the 1.0 times 10 to the negative 7th plus the 1.14 times 10 to the negative 8th. And when you do that, because this is the concentration from the water, this is the concentration from the hydrochloric acid. So now when you find the pH of your new thing, it's just slightly acidic, okay? Slightly acidic. This is a very, very, very much a weak acid. Would that amount of hydrochloric acid cause any problems?
No, barely acidic.
Yeah, it's barely acidic, okay? And we don't think about it. That's 7 zeros in front of it, so we don't really do anything that's that weak. Okay, we use a lot of 0.1 molar, 1 molar, 2 molar. So this is a very, very low concentration of this hydrochloric acid. Okay, so that's just a tricky problem in that. So the strongest acid is H3O plus. Okay, that's what we kind of talked about with this. And this is how we're going to kind of go into this. The strongest base is OH minus. Let's go back to the beginning of acid bases when we had to write our conjugate acid base pairs. Okay, and we knew that if it was OH minus, it was always a base. We knew if it was H3O or H plus, it was always an acid. Okay, all bases that are weaker than OH minus will form an equilibrium mixture. So now I need to start classifying some things because a question can be, and I will ask this question. AP exam will ask this question. I would even say your basic Chem 1 class in college would ask this question. I want you to compare which acid is the strongest, okay? It depends on the ease, how easy the hydrogen can be removed, okay? The stronger the bond between atoms, the weaker the acid, okay? Because if the bond is stronger, it's harder to break apart, correct? We know a strong bond is a hard bond to break. So if it's a hard bond to break, there will be less ionization that will occur. The weaker the bond, the stronger the acid. The stability of the resulting ions. Typically, here's the biggest thing to take out of this whole slide. This is based off of the periodic table. Okay. So if I'm looking at the periodic table, what's the top element of the periodic table in the halogens? It's F. Okay. It's F, then Cl, then Br, then HI. Okay. So the strongest binary acid is typically HF. Now, this is kind of a weird thing, isn't it? Why? Why does HF has the strongest, has the most strength? And that's the word. HF has the most strength. Why is that interesting?
Because
because it's not a strong acid. Okay, we define as a strong acid as dissociating 100%. Okay, but here we're not talking about strong or weak. We're talking about the strength of it. Okay, so HF is the strongest acid, but it's not a strong acid
So how's it a strong acid if it's not a strong acid?
because it only dissociates. So when you decide if something's a strong or a weak acid, you're looking at the dissociation level of dissociation. It only dissociates 95% of the time, or approximately. So approximately 95% of it dissociates. However, even its strength is greater because it is an easier bond to break. Okay, it's an easier bond to break. So, and this is why,
Yeah,
the stronger the bond, the weaker the acid. Okay,
Oh, right.
the stronger the bond, the weaker the acid. And we know that it has a very high electronegativity difference. Okay, I said that backwards. HF would be the least. I said that back. HF would be the least. However,
HF will be the weakest,
not
not the strongest.
yes, and that does make sense. But what do we know about HF? This was I was really going with this. What do you know about HF? Hydrofluoric acid. What? It's got a full. But what do you know about it?
Associates 95%.
I mean, what do you know about it in like chemistry terms, but in chemistry terms? What can HF do? I mean, pretty much all your crime scene shows. What's it used for?
Blue lightness, isn't it?
Nope.
Fingerprints.
Dissolving bones.
Yeah, but okay, why would we just?
No one's ever watched. Never watched a TV show of like someone a crime scene show and the person's trying to get rid of it, so they put it in a container of hydrofluoric acid.
I've seen them put it in acid, but
When they're talking about the acid, they're putting in typically hydrofluoric
I've
acid.
never realized that.
Yep.
Never paid.
And so same thing here.
Good to know.
Same thing here. H2O is the top of it is definitely the weakest one. Okay, I'm not comparing.
HI is the strongest.
Uh-huh.
Wow.
I'm not comparing in between these two categories with this. Okay, I'm not comparing in between H2O and HF with this. So now oxyacids. Okay, oxyacids is a substance that contains hydrogen, oxygen, and other elements. We're dealing with a lot of oxyacids. Nitric acid, sulfuric acid. Typically our non-binary acids in here are the same. So if you increase the oxidation state, increase the oxidation number of the central atom, okay? So that's also talking about the formal charge of that central atom would increase the strength. More oxygens, because oxygen is very electronegative, would increase the strength of the oxyacid. So for example, and we know this, nitric acid is a strong acid, isn't it? Nitrous acid is not. Okay, nitrous is not. Nitric is. HNO3 is. Okay, you could do the same thing with H2SO4 or those there. I had those coming. Okay, we know that these two, chloric and perchloric, are strong acids, and we know that these are not. Okay, so this is kind of the science behind this. Okay, the things that we know.
More oxygen atoms you have, the
Stronger it is. Now I can't necessarily compare. This is the same thing. I don't want to compare H2SO4 and HClO4. Okay. I don't want to make those comparisons because there's a sulfur in there. When I do that, I will look at some other things. So here we go. So H2SO4 and HSO3, because everything else is the same. The oxidation number is the same on the SE. The number of oxygens is the same on the SE. We know H2SO4 is stronger than HSO3 because S has a higher electronegativity value. What? Go ahead, ask your question. So sulfuric acid is stronger than selenic acid because I'm looking at the same things. But the charge of the central atom is the same. The charge of the SE, the charge of the S is the same. The number of oxygens is the same. So these two are the same strength there. So now to differentiate it, I need to look at the electronegativity differences. Okay. The electronegativity difference, the electronegativity of S is greater than that of SE. So because S is everything else the same, because S is more electronegative, sulfuric acid is a stronger acid. And I don't say that these examples are necessarily the best ones. Okay. I don't necessarily say these are the best ones. because we know sulfuric acid is a strong acid, okay? So looking at this, you could say, if I were to say, so HTE as H2TeO4 and HSeO4, you would look at see, hey, TE has a electronegativity, thank you, of 2.1, and Se has electronegativity of 2.55. So selenic acid would be stronger. Okay, selenic acid would be stronger. Same thing here. Now, in these, and we know that chloric acid is a strong acid, but Cl has a greater electronegativity value than Br. So the chloric acid would be
I
stronger.
thought you said it's the one with the most electronegativity that's strong.
Yes, that's what I said.
Oh, okay.
Isn't that what I
Did you
said?
say selenic acid is strong?
So selenic acid is stronger than telluric acid.
Oh.
Okay, than telluric acid, not sulfuric acid, because selenic acid has an electronegativity value of 2.55. Tellurinium has an electronegativity value of 2.1. Most have hydrogens attached. Some do not. Okay, some do not. Some with oxy acid. So H3PO4 is stronger than H3PO3 is stronger than H3PO4 because one of the H's in phosphorus acid is connected to the.
Wait, what?
Let me draw this one out. So, continuing on with oxy acids. Wrong thing. So here's where we're trying to get to today. Okay, the stronger the acid, the weaker the conjugate base. Okay, so we know that salts can be acidic or basic. Okay, we know that salts can be acidic or basic. This is going to determine whether things are acidic or basic. So the first rule is the stronger the acid, the weaker the conjugate base. Okay, that's just how that works. So strong acids have a very weak conjugate base. Okay, strong acid, weak base. Weaker acids have a stronger conjugate base. That means their Kb values are larger. This is the same thing with conjugate acids. The stronger the base, the weaker the conjugate acid. The weaker the base, the stronger the acid. Okay. So an acid-base reaction, the reaction that is favored is the reaction that produces the weaker acids and bases. Okay, the weaker acids and bases. Example. NaOH is a strong acid, correct? HCl is a strong base, correct? So the conjugate.
Wait, I thought HCl was strong acid and
Did I say that backwards?
Yeah.
My bad. So, sodium hydroxide is a strong base. HCl is a strong acid. So we know that they're both going to produce a weak salt, correct? Because this is strong, so over here has to be weak. This is strong, so this has to be weak. So that's why this, well, here we go, stronger acids and bases. So these are weaker acids and bases, okay? That is how the, how this works, okay? And this is very important when we do this, okay? This is very important when we do this. So
So is water considered a salt here?
no,
not the base.
No.
Right? How's it not a base?
water is just considered water here, okay? The salt, remember, a salt is defined as an ionic compound, okay? So this is not ionic. That's a polar compound. So that the salt here, not integrated, in this case, it's table salt, but because it's an ionic compound, electronegativity difference is greater than 1.7. So hydrolysis is the reaction of substance with water. Okay, sometimes happens with salt. There we go, salt and ionic compound. Reaction produce H and OH. We consider them acidic or basic. So here's my question. And this is where we're really getting with today's lesson. Is this thing sodium acetate? Is sodium acetate acidic or basic?
Is it basic?
Okay.
Yeah, I'd say it's basic.
So where does the Na come from?
Probably from a base.
From sodium hydroxide, okay? So the Na comes from sodium hydroxide. Well, there's our equation. I'm gonna hit that. Oh, did I do this? I'm too far ahead of myself. I'm sorry. I'm ahead of myself. What I want to do. So consider the acidic or basic. So there's my equation. And this one here, do the same thing. NH4. Have it like that. Okay. I'm ahead of myself. That's where I want to be. Okay. So if the cation comes from a strong base and the anion comes from a strong acid, the salt will be neutral. Okay. So NaCl would be neutral, wouldn't it? Because the Na came from a strong base. The Cl came from a strong acid. So that would be neutral. So strong and strong make neutral. We pull the same strong and strong makes neutral. If the cation comes from a strong base and the anion comes from weak acid, the salt will be basic. So here's my example of this. This is where I thought it was a while ago. Na comes from sodium hydroxide. That's a strong base, isn't it? Acetic acid acetate comes from acetic acid. Is this a strong acid or weak acid? It's weak acid. So a strong base and a weak acid would make what? Would it be more basic or more acidic?
Okay.
Sodium acetate comes from a strong base and a weak acid. So would the salt, sodium acetate, be slightly acidic or slightly basic or neutral?
Be more acidic.
No,
More basic.
more basic.
Why?
Because the salt comes from the base. Because if the cation comes from the strong base, the base wins out. So there's more base pulling, okay? There's more base pulling. And I'll work some more
I
examples.
was thinking conjugate acid.
Yep. So this would be opposite. So NH4 comes from ammonium hydroxide, correct? Is ammonium hydroxide a strong base or a weak base? Ammonium hydroxide, strong base or weak base? Weak base. Remember, our strong bases come from group 1 and group 2. Okay, our strong bases come from group 1 and group 2. Not francium, not magnesium, not beryllium. Okay, so our strong bases come from group 1 and group 2. NH4 does not come from group 1 or group 2, so it would be a weak base. Cl comes from hydrochloric acid, correct? So would that be a strong acid? So a weak base and a strong acid would make something what? Acidic. Okay.
So it's like whichever one is the strong.
It's like positive and negative,
not the basic one.
Both correct. So these have been the simpler ones so far. Okay, we know that if it's strong and it's strong, it makes neutral. And we know if one thing's stronger than the other, if one thing's strong, one thing's weak, the strong thing would win out.
If it's weak and weak, it's neutral.
Well, if weak and weak, maybe not. That's where I'm going with this, okay? This, if it's weak and weak, it may or may not be neutral. In this case, you would need to compare the Ka and Kb value, okay? So if the Ka is greater than Kb, it's acidic. Because it's telling you, because remember, the bigger the Ka value, the stronger the acid. The bigger the Kb value, the bigger the base. So if Ka is greater than Kb, it is acidic, okay? Because it would be a slightly stronger acid. Other hand, if Ka is less than Kb, it's basic. Kb would be bigger. If they are equal, the salt is basic. Okay, which is very rare. I didn't know. I just want to make sure I didn't have one more. This is what your homework's about today. Yep.
My psychiatrist is my practitioner.
That's probably what I'll do. I'll probably want to something like
All right. So example of this: NH4Cn. NH4 comes from a strong or weak base. Weak base. Cn comes from a strong or weak acid. Weak. HCN is a weak acid. So I cannot just automatically assume it's neutral. Okay, because if it's a weak and a weak, I just cannot make that assumption. If it's a strong and a strong, I make the assumption and it's neutral. Okay. So in this case, I have to compare the Ka values. So NH4 has compare the K value. NH4 comes from NH3, and it has a Kb value of 1.
Will the KB be given?
Sometimes yes, sometimes you got to go look it up. Okay, but I mean, you're never asked to memorize the Kb. Okay, so it might, like on your homework tonight, besides say given in the problem, but you probably should go look it up in there's a table in your book, or you can just Google what's the Kb value of that. Okay.
Will it all be pretty similar?
What?
Will it all be like pretty similar?
Yeah, I mean, it might get 1.82. I don't know the exact number, but yeah, I mean, it would be close enough. So that comes, so HCN comes from cyanic acid, so it is a Ka value of 4.0 times 10 to the negative 10. So is this acidic or basic? You're given the Kas and Kb values, so is this acidic or basic?
We're all right.
Basic. It's got a bigger KB value.
It's basic because it has a bigger Kb value, okay? Keep in mind the negative exponent means it's further away from zero, so this would
When it's equal, what is it?
be basic. When the weeks are equal, when the Ka, Kb value, it would be basic.
Did I miss anything? I don't believe I did.
No, you didn't do your ice box on one of your homeworks. You did the first one, then just didn't do the second one. You said, I don't understand this. You did the first one correct.
Oh, no, the third one. It was,
Third one you have to do.
Yeah, you didn't say that.
Oh, well, Riley should have told you. My bad.
I didn't
We didn't
know
work the
that.
next day in class.
I was just trying
I'm
to.
You
not
should have
a
emailed me. Yes, I'm
teacher.
sorry. I'm sorry. I did.
I did 1 and 2, and then on the third one, it was like completely different.
Yeah.
I didn't
I
understand.
didn't think
Yeah,
you
we
did too.
learned that the next one.
All right. Any questions about this?